All right, so we are, I didn't put the section number on there. So we're doing worksheet 15. The last one we did was 14, so now we're doing 15. Okay, now, I don't understand why it got so loud when I'm actually started to teach. I just don't get it. And here's the name of this. It's called the Pythagorean Theorem. I don't think we have done this in this class, have we? I don't think we have. I don't think we've done it in this class, but you should have had it. You should have had this in Algebra 1. You should have had it in Geometry. You should have had it in Algebra 2. So this should not be your first time hearing about Pythagorean Theorem. But I thought it'd be a good refresher for you since you haven't had it in a really long time. So let's talk about this. No, you haven't had this in at least a year probably.
You said you missed us. You said you missed us, not like break.
I lied. All right, here we go. So, by the way, everybody settled in? Taking good notes there, Jordan? So here we go. The Pythagorean Theorem. It's a weird name. Why in the world did they pick Pythagorean? Well, it's named after a guy, Pythagoras. And he lived, I forget. I just taught this not long ago to my geometry class, and I forget what the dates were. You can look it up. He lived, I think, hundreds of years before Christ, 500 BC maybe, if I'm right. I don't know. You can look it up. He's been around a long time. And you would think, I still hear talking. You would think they named the theorem after him because he's the one that came up with it, wouldn't you think? But they didn't really name it after him because he came up with it. They actually knew about the Pythagorean theorem, what we're going to teach right here, hundreds, if not thousands of years before Pythagoras, which is amazing because we think way back then, how in the world did they know anything? They were just like chiseling it on stone, that kind of thing. No, they weren't. They actually knew a lot of stuff. They knew a lot of math, and they knew about this particular theorem. The reason why they call it the Pythagorean theorem, named after Pythagoras, is he's the first one that came out with a nice formal proof of the Pythagorean theorem. Okay. Now, in this class, in some classes, I do go through one of the proofs for the theorem. I'm not going to today. All right, I'm just going to show you what it is and how it works. Okay, I think that's all you're going to care about right now with only 2 or 3 weeks left in the year anyway. So let's just do this. The Pythagorean theorem can only be used with right triangles. Okay, write that down somewhere. Okay, that's the symbol for triangle. Looks like a triangle. So you can only be used with right triangles. Okay, it's not used with an acute triangle. It's not used with an obtuse triangle. If you know what all that stuff means, it's only a right triangle. How do I know this is a right triangle? That little box right there. That little box right there represents it's a right triangle. What does that mean? It means it's a right angle. How many degrees is a right angle? It's 90 degrees. So you learn stuff in geometry. So that's 90 degrees. This is a triangle that has one 90-degree angle in it. Can you have more than one 90-degree angle in a triangle? Why not? Because you only have 3 sides? Okay, that's what I want to hear. All the angles inside this triangle can only add up to 180 degrees. And how many angles would there be in a triangle? 3, okay? So if I have 2 90-degree angles, what's my other one going to be? I can't have a 0-degree angle, though, inside of a triangle, okay? So I cannot have 2 90 degrees. I'm waiting. You also cannot have a 90-degree and an obtuse triangle or angle. What's an obtuse? What does that mean?
Bigger than 190.
Bigger than 90. It's bigger than 90. So I can't have 2 90s. I can't have 2 obtuses. I can't have a 90 and an obtuse. Okay? That's the biggest angle inside of a right triangle is the 90-degree angle. Okay, everybody hear me? That's the biggest angle in a right triangle is the 90-degree angle. So the other two have to be what kind of angles? We've mentioned the word before, acute, which means that they are smaller or less than 90 degrees. So these two angles are acute. There's something else that must be true about these two angles. Remember, all three add up to 180, correct? So if this is 90, tell me something about this angle up here and this angle down here. No, you can't say they're 45. What is it? They have to add up to 90 degrees, okay? Because if all three add up to 180, and this is 90, 180 minus 90 is 90, right? So that means this one plus this one have to add up to 90. Are they necessarily both 45? No, they're not, okay? This could be 30. Then what's this angle right here? It's be 60, okay? If this was 20, then this would be what? 70, because we just take them away from 90 degrees. Everybody with me? Okay. But that's really not what we're talking about. I just wanted to go through right triangles just very briefly with you. We will talk about this stuff later on, but today we're just going to worry about the sides of the right triangle. So let's get rid of the angles, because I don't know what those angles are, and I don't really care at this point what those angles are. But I do want to talk about the sides of the triangle. What I'm going to do is I'm going to label one of these sides A. I should say this instead of sides, one of the legs. Okay, we'll call them a leg. So this side right here would be a leg. This side down here would be a leg, and I'll call this B. We have a special name for this one right here. I'll call it C, but we have a special name for it. Starts with an H. It's called the hypotenuse, right? That's a word that you've heard quite a bit in the past, so that's not new. Again, this is just a refresher for you. It should be. So we call this the hypotenuse. Now, when I label it A and B and C, it's very important that you recognize that the C is going to be the hypotenuse. You with me? So the C is going to be the hypotenuse. The A and the B are just the two legs. It doesn't matter which one is the A and which one is the B. I could have called this one A. I could have called this one B. In fact, I could have given it other letters. But for this theorem, I'm using the letters A, B, and C. All right? So in this theorem, for the letters that I'm using, the C has to be what? The hypotenuse. Okay, it's got to be it. How do I know this is the hypotenuse? It is the biggest, but that's not why it's the hypotenuse. It's opposite the 90-degree angle. Sounds like Riley's had a good geometry class. So this right here, the hypotenuse, is opposite the right angle. Everybody see it? Here's the right angle. What do I mean by opposite? Well, it's right across from it. See how the hypotenuse does not contain the angle that 90 contains? Or it doesn't contain those sides that 90 contains? So this is opposite the right angle. So that's always going to be the hypotenuse. Everybody got it? And it is true. Somebody said that the hypotenuse is the longest side, and it's absolutely true. The hypotenuse is always the longest side of a right triangle. All right, so that's a lot of information right there. Now, let's go to the Pythagorean theorem and see what it is and see how we use it. So this is how we write it down. I like to tell people the Pythagorean theorem is as easy as ABC. Why do I say it's as easy as ABC? Do you remember what it is? It's a squared plus b squared equals c squared. All right? That's the Pythagorean theorem right there. All right? Super, super famous theorem. Okay? It's used all the time. Anybody with any kind of math background knows the Pythagorean theorem. And that's it right there. Okay? What does that mean? That means if I take the length of one of the legs and square it, take the length of the other leg, square that, add those up, then what's it going to equal? The hypotenuse what? Squared. Okay, it's going to be the hypotenuse squared. Everybody with me? Yeah, let's do an example. Let's do a quick little easy example, okay? So let's draw another triangle. I'm going to draw a specific triangle just to make the math come out real easy for the first one. Well, Maddie better go then. Just don't go in here. All right, let's take a look at this. This is about as easy as the Pythagorean theorem ever gets. All right, so I'm going to start you off super easy, then we'll work our way up, make them a little more difficult. So if I told you that this side was 3, and I told you this side was 4, and asked to find the third side, this is where we use the Pythagorean theorem. This is where it comes in handy. This is used a lot. In fact, I had a kid that I taught years and years ago, and he came to me, we were at some event, and he's like, Mr. Hammer, I got to tell you that I used the Pythagorean theorem just the other day. He was making some kind of garden in his backyard, and he was cutting the pieces of board, right, to make a rectangle, and he wanted to find out what this side was equal to. So he said he actually did use the Pythagorean theorem. He had one board that was this long, another board that was this long, and he wanted to connect them at a right angle like this. And he said, I took my phone out with my calculator on the phone and did Pythagorean theorem to figure out how long that third board should be. And he said it fit perfectly. So that it can be used in everyday life. All right. This is one of the things that is very, very practical. So how do we do this? Let's write the theorem down again so we remember it. Now remember, the A and the B could be either one or the other. It doesn't matter which one it is. It doesn't make any difference. But the C has to be one of these numbers, okay? In this case, we don't know what it is, so we just keep it C. So what do you want to make the A? Yeah, let's make it the 3. Okay, it doesn't matter. I could have made it the 4, but let's make it the 3. So I've got 3, and what do? I don't just go 3 plus. I got to square it. Okay, plus the B. What's the other? Right. So the 2 legs are the A and the B. Again, it doesn't matter which one's which. So that's 4 squared. And what's that going to equal? It's going to equal C squared. I don't know what C is, so I just keep it the variable. I just keep it C. Now let's solve for C. I want to get C by itself. So here's the math. It's not too hard. What do you think we're going to do first? Yeah, square them. All right, so what's 3 squared? That's 9. What's 4 squared? That's 16. And that's equal to C squared. Now let's add. What's 9 plus 16? 25. And that's equal to C squared, is it? I want to find C. I don't want to find C squared. I want to find what C is equal to. So this length right here is not 25. Okay? This is something we've done this year. How do I get C by itself? Square root, right? We did a whole lesson on this, right? Square root. Right? We've done a ton of square rooting stuff in here. So now, what happens to the square root of C squared? That cancels with that. So what's C equal to? It's just 5. It's not 25. It's the square root of 25. Okay? It's the square root of 25, which is different than 25. It's equal to 5. I'm not going to go through all that. We've done a lot of square root stuff. And there it is. So the length of the third side is equal to 5. How do we find it? We use Pythagorean theorem to find it. Now, like I said earlier, it doesn't get any easier than that one right there. All right? Let's do another one that may be a little bit more difficult. Just a little bit, not much. And then we'll go to one that's going to be a little bit tougher. I'm just making these up off the top of my head. I didn't really take notes on this. I'm just making stuff up. Let's say that's 4, and let's say that's 7. Everybody with me? And again, I want to find C. Now that last one came out real nice because I had a whole number. This hypotenuse came out to a nice whole number, right? Square root of 25 comes out to 5. That was easy. We actually have, this is actually a special type of triangle that we'll learn some other time. Watch. We call it a 3, 4, 5 triangle.
Wow.
Oh, yeah, I remember.
Okay? Yeah. And that we also call this a Pythagorean triple. All right? We call it a Pythagorean triple because all 3 numbers come out to be whole numbers. There are other Pythagorean triples. We're not going to talk about them today. Maybe another day we will. But there are other Pythagorean triples that come out where all 3 are whole numbers. But most of the time, you're not going to come out with 3 whole numbers right here. You're going to come out with some square roots. And in this situation is one of them. Let me get my calculator out so that I can figure out what these numbers, because I don't know what that is. All right, so let's do it. Again, what is the formula? It's easy as ABC, right? A squared plus B squared equals C squared. Okay, that's something you should have known before you walked in here. Who was confident when you walked in the door, if I would have asked you what the Pythagorean theorem was, that they would have said A squared plus B squared equals C squared? Okay, about half of you. All right. What about the other half? Do you remember it now that I brought it up?
Yeah.
Okay. Yeah, that's all right. So let's do it. So what am I going to use for A? Yeah, you could use the 4 or the 7. It doesn't make any difference. Let's just do the 4. And then the B has got to be the 7. Now, I don't know what C is, so I'll keep it C. Let's do this. What's that? 16. What's 7 squared? It's 49. And that's equal to what? C squared. So what's that? That's a 15. 65. Is that right? Yeah. Equals C squared. Now watch. Actually, I didn't need a calculator on this one. I got to get C by itself. So this length right here, C is not 65. I don't square it. I square what? Root it. I square root it. So I take the square root. Say what you mean. All right? That's what you got to do. You got to say what you mean. Well, say it. So C is equal to the square root of 65. A lot of you guys would love to put that into a calculator. And if it was a real life situation, like that guy that was measuring, if he measured one board to be 4 feet long, the other one to be 7 feet long, the square root of 65 wouldn't mean anything, would it? If you're measuring stuff out. Okay, so you would definitely put that into a calculator. All right, but we're not doing it. We're not doing, I don't know what to say. So in a high school math class, we're just going to keep it the square root of 65. Okay? That's what we're going to keep it as. No. 64, right? Square root of 64 is 8. So this is what? 8 point something real small, right? Might even be less than 8.1. I don't even know. Let's put it in a calculator and see. 65 square root, 8.06. So it rounds to 8.1. All right? So if he made that board just a little bit longer than 8 feet, right, then it would fit perfectly. Everybody with me? So that wasn't much more difficult. In fact, it might have been easier because I didn't even have to figure out what the square root of 65 was, right? Remember on the other one, we had to figure out what the square root of 25 was to get 5. On this one, I could just keep it square root of 65. Why? Because it doesn't simplify. It doesn't come out to a nice whole number. It comes out to 8.0622577748. I didn't do that in my head. I'm looking at my calculator. Okay? So now, let's do another one. This one's going to be a little trickier. So I started off really easy. And now we're going to have to do a little bit of extra work. It's not much, just a little bit. All right, let's put some numbers in here. Let's say that's 10. Let's say that's 3. And let's say we don't know that one right there. I'll call it X. Or I'll call it B. Make it easier for you. Why did I pick B? Because ABC, right?
Oh, yeah.
Okay. Now watch. Here we go again. Let's write down the formula again. At this point, everybody in here should have this memorized. Guys in the first table right here. There's a lot going on. I don't understand. So what we're doing is we are not finding, exactly right, we are not finding the hypotenuse this time. Now we're finding one of the legs. So, but let's put the stuff in there that we know. Do we know one of the legs? We'll call it A. Yeah, it's 3. So I put 3 what? Squared. Plus, what's the other leg? Don't know. It's B, isn't it? So I just put B and I square it. Now this time, I do know what the C is. I do know the hypotenuse. What is it? It's 10. So it's 10 what? Squared. Now I have to do a little bit of algebra. This is the only part that's a little trickier. It's really not much harder. It's a little bit, just a little bit harder than what we did before. All right, so let's write the stuff down. What's 3 squared? 9. Plus B squared equals, what's 10 squared? 100. Okay? And now, what do we do to get b by itself? Subtract a 9. That's really the only thing different on this problem than what we did earlier. So it's really not that much more difficult. So I subtract a 9 from both sides. Okay, that cancels out. I bring down the b squared. What's that equal to? 90. How about 91? Now, b is not equal to 91. What is it? It's the square, what?
Square root.
Root of 91.
That's not going to be a whole number. That's going to be a fraction. Be a decimal, right?
Yeah, it's going to be a decimal, but in high school math class, what do? We just keep the square root.
Wait, then why do we...
It's about 9.5 something, okay? It's not exactly 9.5, but it's about 9.5. Now listen, this, I'm going to answer your question. This right here is an exact answer. It's exact. Okay? If I would have put it into a calculator and got a decimal, that would be an approximation because my decimal keeps on going forever. You see it? It keeps on going and it never repeats. All right? It looks like a bunch of random numbers. Okay? It's 9.53939. It looks like it starts repeating, but then it goes 2014 and then who knows what else is after it. All right? So if you wanted to write it as a decimal, I'd put a little squiggly equal sign. What does that mean? Right, approximately 9.5. It's 9.53, so the 3 does not round the 5 up. So we put approximately 9.5. It's not exactly 9.5. It's approximately. So this is approximately, I'll just shorten it to approx. Okay, this is exact. The problems that you're going to see, yeah, some of them say keep them in radical form. What does that mean? With a square root. So some problems, listen, some problems say keep your answer in radical form. Some say round it to the nearest tenth, right? So this would be in radical form. This would be rounded to the nearest tenth, all right? So it's important that you're able to put it into a calculator to get that because depending on the problem, they give you different instructions for each of these problems, okay? So one section says write it, what do they say? Simplest radical form, all right? And some say write it, round it to the nearest tenth, right? So this would be rounded to the nearest tenth. This would be in radical form. You with me? All right. There's one more part that we need to get to that we didn't quite get to, but you should be able to do the first page. Yep. You should be able to do the first page of this worksheet. It's only 8 problems, all right? So today you're only doing 1 through 8. Tomorrow I'm going to teach the second half of this, and then you'll do the second page of this worksheet. Okay? Question. It depends how they ask you on the test. So you got to read the instructions. If the instructions say write it as a radical, you got to write it like this. If it says to round it, then you write it as approximate. Guys, hey, I'm trying to talk. I do make the test, and I could say either way. I'm going to make it just like the quiz, or just like the worksheets, okay? So I could ask the question exactly the same as they do on the worksheets, all right? So sometimes you write it as a radical, sometimes you make it as a decimal, okay?